Hi, this is a walkthrough of week 3, day 2, Introduction to LangChain and LangChain Expression Language. So we're going to review how we can use LangChain to coordinate a number of tasks that involves using language model as an agent. And we're going to put together a RAG application by using a text data as a corpus before we can ask questions and only use the vector database of the transformed text chunks before coming up with the answer. So we're going to install some libraries, set some environment variables, and answer a number of questions related to a LangChain expression language. And then we'll demonstrate how to put together a RAG application using Quadrant, OpenAI, and LCell. So we install a number of libraries. There's a core of LangChain. There's a third-party developed libraries called LangChain Community, and an integration tool called LangChain OpenAI for OpenAI. We also install Quadrant for our vector database and some document loader to load up our Pi PDF document. We're going to pass in our OpenAI API key. We're going to start using LangChain LLM orchestration tool, and we're going to use a GPT-4.0. First question is, are there other models available? Yes, you can use OpenAI, Anthropic, Azure, Google, and so on and so forth. This is what LangChain supports right now, and then I'm sure it's going to be much more later on. And what's nice thing about LangChain is it gives you essentially wrapper codes that makes the coding much simpler. So for instance, there's a chat prompt template that we can use to pass the system prompt as well as the user prompt, which LangChain calls it human template, along with the assistant or AI message prompt as well. And LangChain offers three different ways of interaction. One is the invoke, one at a time. It also does async, which is a asynchronous interaction, and there's a batch for a batch of multiple prompts together, and of course, the streaming as well, the real time. Another nice thing about the LangChain is the fallback, so that in case something fails, like the rate limit, it'll quickly switch over to the alternative method without human intervention. And parallelism, which means that you can invoke multiple tasks to get simultaneously, which makes the scaling very easy to do, which is the answer to the question later on. So, for instance, the example is simply you pass the first task, which is feeding the chat prompt, and then the output of that, we're going to feed it into the language model to grab the response. So here's an example of a feeding the prompt and using the invoke, then put it into the chat prompt, and then the language model will return the response. So here's an example of that. So one issue with this using a language model to get a answer or a response is that it may provide false or hallucinate. So we're going to use RAG to make sure and guide the language model to only answer based on available information that is correct. So we're going to pass the um, lookup value or answer as part of the prompt as a context, and then guide the language model to only use the context to answer a question. So we're gonna quickly move over to illustrate an example. So here we are providing essentially answer as part of the context here, as part of the prompt template, so that when we invoke LangChain to ask the OpenAI to provide the answer, then it'll provide the more correct answer without hallucinating. So task number 4 is we're going to try to do this with LCell, and we're going to load up a model for GPT-4o, and then we're going to use a text splitting as the chunking strategy. And we'll see that there's three chunks. So we can see that there are three chunks separated by the dashed lines here. And incidentally, there are other strategies of chunking the text. In addition to the character splitter, which is using a line character or line return. We can also use a tag such as HTML or XML or JSON tags, and this can be very useful if you're doing controlled vocabularies domain, like healthcare or finance or other industry where controlled vocabulary has certain meaning that separates certain sections and so forth. Another strategy is semantic chunking based on semantic similarity, but so all of these are available on LangChain libraries. And the third approach is hybrid, where you combine a higher level construct such as chapter page number to separate corpus into smaller sets of text documents. And then once you have that smaller chunks, then use something like a line separators or paragraph separators as the lower level approach. And this is also known as hierarchical. Then we're going to move on to the embeddings, and this is very similar to what we've covered in the previous weeks. We're going to use OpenAI's small model, and this has a 1536 as the default dimension, which can be changed into smaller dimensions by using a dimensions parameter like 512, which is what we did last time. And of course, larger models have more dimensions than the others. So we're going to use this chunk to convert text into vectors. And once we have that, we can at least verify that, yep, there's a 1536 because we haven't changed anything like that. And this allows us to use a cosine similarity. So for instance, if you ask this question, which of these three vectors is most similar based on cosine similarity? And we can see that based on that question, the cosine similarity of 0.54 indicates that this chunk is most similar. So the idea is that we're going to package it into a function. So we can just use a one line of code to call them up and extend it by using vector database as the storage of all the lookup or the answers, which allows to use a cosine similarity to compare a question. So now we can apply it in a larger context and scale. So the question number three is, so LangChain expression language allows you to do this without making a lot of errors, which may happen when you are writing codes. And if you do one at a time, the coordination will likely result in error. So by wrapping all the codes in a nicely package, we can reduce that. And in addition to that, we can LangChain provides a number of features like parallel execution to allow you to run multiple codes at the simultaneously, provides access to intermediate results for debugging, troubleshooting, fallbacks to automatic conditional execution based on available and not available resources like rate limiter, traces, and Langsmith, which offers deployment toolkits that makes scale easier and more reliable. So let's move on to the task number five, which is putting all of this together in a one bucket. So we're going to download some transcript from Steve Jobs' talk on iPhone with the PDF document loader. We're going to chunk our documents with 200 as the size of the chunks using LangChain's recursive character text splitter. And then we're going to go ahead and incidentally, there's largest one is 197. That looks good. So then we're going to put it into Quadrant. This is an in-memory database, which means the database lives inside the RAM. And once we have that put together, and then we're going to go ahead and ask the question by constructing the prompt template and referring to the context, which then points to the vector database. And we're going to use the language model from OpenAI to uh, package the delivered answer from Quadrant with the original query before we deliver the final output to the interface. So, and that is represented pretty nicely here. We have two paths, one to pass the question or query into the chat OpenAI for final construction. We pass the same one as a lookup to the Quadrant vector database. And once it returns a number of contexts that has the most similar result, then it will be used uh, together with Chat OpenAI, which will do the final construction of the response. So here's the one illustration. What's the most important thing about iPhone? And it does it pretty well. The most important thing about iPhone is the um, create the ultimate digital device, and so on and so forth. And we can also see the context, the original document, along with the metadata like the page numbers and keywords and so forth. And of course, if you ask a question that is unrelated, then it should say, I don't know, because that was put into the prompt template as well. So the final question is, what if we ask a different question? What is the key innovation in the iPhone? So I just simply copy the codes and simply adding the key question here. What key innovation did the iPhone introduce? And the answer is these are the key innovations, including widescreen iPod, revolutionary mobile phone, breakthrough internet communication device, and so forth, and also a proof or the evidence of the response with the context. Thank you.